All right, section 3 is about properties of logarithms. All right, there's some interesting properties of logarithms that allow us to either expand or condense a logarithm. All right, and the first rule is called the product rule. The product rule states, okay, that if you have the log, regardless of the base, and then inside the logarithm you have two separate things, two factors, two things that are multiplied, that you can break it out as the log of the first thing plus the log of the second. Okay, so it's the product rule. Multiplication on the inside is addition on the outside. All right, so let's look and see what that looks like. The log base 4 of 7 times 5, is I could rewrite that as the log base 4 of 7 plus the log base 4 of 5. So it's 7 times 5 in the inside of the logarithm. I can break it out as the log of the 7 plus the log of the 5. All right, B, we'll do the same thing. We've got the common log, because there's no base, it's understood to be 10. So we have the common log of the first part, 10. Since it's 10 times x, so the log of 10 plus the log of x. Multiplication on the inside, addition on the out. All right, and on that one we can actually simplify it. Since this is the common log, the base and the argument here are 10, and so they are the same. So the answer is 1. So this gives me 1 plus the log of x. All right, pause it, see if you can do that same stuff for the checkpoint. All right, here answers for A. We're going to have a log base 6 of 7 plus log base 6 of 11. Multiplication on the inside is addition on the out. For B, our first step, we can write this as the common log of 100 plus the common log of x. Since it's 100 times x, it becomes the log of 100 plus the log of x. All right, we can simplify this one. Since the base of the common log is 10, 10 to what power gives me 100? Well, that's 10 squared. So we're going to have 2 is the answer to the log of 100 plus log x. 2 plus log x. All right. The next rule is the quotient rule. All right. If you have a division inside my log, I can take it the log of the numerator minus the log of the denominator. Log of the numerator minus the log of the denominator. So let's see how this works. On A, we have the log base 7 of 19 divided by x. So we're going to have the log base 7 of the top number, 19, minus the log base 7 of the x, the bottom number, the denominator on the bottom. That's it. On B, we can write this as the natural log of the top part, the numerator, e to the third, minus the natural log of the denominator, the bottom, which is 7. All right, on this one we can also do a little bit more work. Since the base of the natural log is e, then the natural log and e cancel out, and you're just left with 3 minus the natural log of 7. So we either use the rules we learned in the last section to simplify that even more. All right, try the checkpoint. Go ahead and pause it. All right, the answers to this one, I've got log base 8 of the top, which is 23, minus log base 8 of the bottom, which is x. For B, I've got the natural log of e to the 5th, the top, minus the natural log of 11, which is the bottom. And again, that will simplify a little bit more because the natural log has a base of e, and the argument of the natural log is also e, so those cancel out and I'm left with 5 minus the natural log of 11. That is the quotient rule. All right, and then one more rule is the power rule. If inside here you have a power, in the argument you have a power, you can actually move the power to the outside and multiply it by the whole logarithm. Okay, so let's look and see what we can do with that. The log base 5 of 7 to the 4th, I can rewrite that as the power out front times the log base 5 of 7. All right. For b, let me rewrite it. It's the natural log of the square root of x, but I'm going to rewrite the square root as the 1/2 power, which I can now move that power out front. So it becomes 1/2 natural log of x. If you have a power, you can move it to the front. All right, for c, I've got the common log of 4x raised to the 5th power. So I can bring that 5 out front and have that as log of 4x. Okay, bring the 5 out front. Now I can also on this one break it up even further using the product rule. Since I have two things inside here, I can rewrite that as 5 of log of 4, all right, plus, actually I need to have a parentheses here, or a bracket, the log of x. That 5 goes in front of the whole thing, it's going to go in front of a parentheses and then those two parts. All right, go ahead and pause it and try those problems. All right, here we go. For A, we're going to bring the 9 out front. So 9 times the log base 6 of 3. For B, I could rewrite that as the natural log of x to the 1/3, because the cube root is the 1/3 power. And so in turn, I can use the power rule to write it out as 1/3 times the natural log of x. All right, and then on C, I've got log of x plus 4 squared. So I can bring the 2 out front and say this is 2 times the log of x plus 4. All right. Now, I can't break that apart. Addition on the inside I cannot break apart. If it's multiplication, I could. All right, so here are kind of all the properties together. Okay, and so we can use that to expand log as much as possible. Okay, so let's look at this one. A, I've got log base b of x squared, the square root of y. All right, now I'm going to notice that there is a multiplication in there. It's x squared and then it's the square root of y. So I can use the product rule to break this out as log base b of x squared plus the log base b. But I'm going to go ahead and rewrite that as y to the 1/2 power. Square root of y and y to the 1/2 power are the same. All right, and then I can use the power rule to bring those powers out front. So this becomes 2 log base b of x plus 1/2 log base b of y. Okay, so I use the product rule to break it apart first, and then each of the individual powers I can bring. All right, B, biggest thing I see is the division, so I can use that quotient rule. So this becomes the log base 6 of the top part, which I'll rewrite as x to the 1/3, minus log base 6 of the bottom part, which is 36 y to the 4th. All right. Now, in that second log, I've actually got multiplication again, so I can actually break that up even further. So I'm just going to rewrite log base 6 of x to the 1/3. All right, minus, and I'm going to put a parentheses. Since there's a minus, I need a parentheses since I'm going to break this apart. This becomes a log base 6 of 36 plus the log base 6 of y to the 4th. That multiplication becomes addition. All right, and I'm going to do one more thing to simplify. The powers can come out front, so that becomes 1/3 log base 6 of x. All right, I do need to distribute that minus through. So that minus is going to go in front of the first and in front of the second part. So I'm going to have minus. All right, log base 36, I can actually work that out. 6 to what power gives me 36? 2. So log base 6 of 36 becomes 2. And my distributive, I'm going to have another minus. And now that exponent can come out front. 4 times the log base 6 of y. And if there's nothing left inside the log that's multiplication or division, there are no more powers, we've expanded as much as is possible. All right, pause it, and then to try the next problem. All right, here you go. I can rewrite this as log base b of x to the 4th plus the log base b of y to the 1/3. All right, and then I can bring the powers in front. 4 times the log base b of x plus 1/3 times the log base b of y. And that's it. On b, I can break it apart since it's division into the log base b, or log base 5, excuse me, of the square root of x minus the log base 5 of 25 y to the 3rd. All right, I've got multiplication in that last one, so I can use that product rule. So I have a log base 5. I'll rewrite that as x to the 1/2 power. I'm going to put a minus and then a parenthesis since I'm going to break that up. I'm going to use a bracket here. So log base 5 of 25 plus the log base 5 of y to the 3rd. All right, and then I can use distributive and power rules. The 1/2 comes out front, so 1/2 log base 5 of x. I distribute the minus, so I've got minus 5 to what power gives me 25? There's a 2. And then minus again, I can bring the 3 out front, make it 3 log base 5 of y. All right, and so that's how you expand. All right. Now the opposite of that, expanding, is condensing. All right, so if you see addition on the outside, that becomes multiplication on the inside. Subtraction on the outside, division on the inside. You got a number in front, it becomes an exponent. All right, so we can write these as a single logarithm. We have addition, so we can rewrite this as log base 4, and on the inside we can make that 2 times 32. All right, which on this one I can actually multiply that out. Log base 4, 2 times 32 is 64, which is actually nice because I know what that is. 4 to what power gives me 64? Well, 4 squared is 16, and 4 to the 3rd is 64. So this answer is 3. All right, but addition on the outside becomes multiplication on the inside. On B, we have subtraction on the outside, so this becomes division on the inside. So I end up having log of 4x minus 3 on top divided by x on bottom. All right, pause it and try your checkpoints. All right, here you go. This becomes the common log of 25 times 4. Well, that's 100. And since the common log has a base of 10, 10 squared is 100, so the answer is 2. On B, we have subtraction on the outside. So that becomes the common log of the first part, 7x plus 6, over the bottom x. All right. A little bit more work with these. Okay. On these, on A, we actually have powers in front. Let me rewrite the problem. I've got 1/2 log of x plus 4 log of x minus 1. So I can actually bring the numbers out in front as powers. So this becomes a log of x to the 1/2 plus the log of x minus 1 to the 4th. I brought up the powers. All right. And then I can, since there's a plus in between the two logs, I can put these together with multiplication. So this becomes log, put a bracket here for the argument, x to the 1/2 I can rewrite as the square root of x, and then times x minus 1 to the 4th power. It's all together in one logarithm. All right, for B, I've got 3 natural log of x plus 7 minus the natural log of x. All right, when you're doing these problems, you will do, if there's numbers in front, you want to bring those up first. Okay, so this becomes the natural log of x plus 7 to the 3rd power. The 3 comes up as a power. And then minus natural log of x. And since you see subtraction, that turns into addition, or excuse me, division. Subtraction turns into division. So x plus 7 to the 3rd divided by x. If you want to put a big bracket around it, you can, to make sure that I know that that's all inside the natural log. All right, and then finally for C, I've got a lot of stuff going on. 4 log base b of x minus 2 log base b of 6 minus 1/2 log base b of y. Let me move all my powers first. So this will become log base b of x to the 4th minus log base b of 6 squared. Again, the power comes up, minus log base b of y to the 1/2 power. So powers first. All right, now I see subtraction. I actually see 2 subtractions. Okay, and so kind of a shortcut here, if you see a subtraction to subtraction, whatever has the minus in front of it is going to go on the bottom. So this is going to become log base b. We're going to have x to the 4th up top. All right, and then on bottom, we're going to have both the 6 squared, which becomes 36, and y to the 1/2, which I'm going to go ahead and write as the square root of y. So the 6 squared became 36, y to the 1/2 became the square root of y, and since they had minuses in front of them, those went to the bottom. All right, give it a pause and try the checkpoints. Actually, that checkpoint was one we've already had, so never mind. Okay, those answers again were log of 100, which is 2, and log of 7x plus 6 divided by x. All right, and then lastly here, we have the change of base property. All right, and we can do it one of two ways. We can either use the common log or the natural log. Okay, and this is beneficial when I have a base, an argument, which are not, or the argument is not a power of the base. Okay, it's how I can find these answers. Okay, and we have our calculator help us out. All right, but what it says is if I have a log of any random base to any argument, I can turn that into the common log of the argument divided by the common log of the base. Or I can turn it into the natural log of the argument divided by the natural log of the base. And then I stick that in my calculator and I get an answer. Okay, your calculator should have a log button, and it also has an LN button. Those are really what you press to do these problems. All right, so let's look at example 7. Use common logarithms to evaluate log base 5 of 140. All right, I'll pull my calculator up. All right, first thing you're going to do is you're going to rewrite the log base 5 of 140 is going to be equal to the common log of 140 divided by the common log of 5. Okay, log of the argument divided by the log of the base. Then you go to your calculator, you're going to type in, you hit the log button, all right, and then parentheses, 140 divided by, close parentheses first, got to make sure you close parentheses, divided by the log of 5, close parentheses. And you should get 3.070. 3.070. All right. Now, you can do the same thing with natural logs. Example 8 here says use the natural logs. All right, and so we have the log base 5 of 140. We can rewrite that as the natural log of 140 divided by the natural log of 5. All right, and it's exactly the same thing. It's going to give you exactly the same answer. You're just using a different button press in your calculator. You're doing natural log, hit that LN button, of the 140, close the parentheses, divided by the natural log of the 5. Make sure you have parentheses on those. And it's going to give you exactly the same thing, 3.070. All right, pause it and try the checkpoints. All right, using common logs, this becomes the common log of 2506 divided by the common log of 7. All right, which would I stick in my calculator? That gives me 4.022 when you round it to 3. 4.022. All All right, for checkpoint 8, we have the natural log of 2506 divided by the natural log of the base 7, which should give you the same thing, 4.022. All right, try these out. Work them on MyMathLab. Email me if you have questions.